Hello everyone. Welcome to another day of daily LeetCode Live, where we do LeetCode questions. We see how many we can do. We have fun with LeetCode. We try new things out, and we overall just have a good time. I was supposed to come to you all a little bit later today at around 5 p.m. Eastern, but I decided to do a little bit earlier as I have some things to do tonight. So I just want to catch up on that and make sure that I have ample time to do my errands tonight. Now, as I promised in Tuesday's stream, today we're going to resume our LeetCode Live, and we're going to be doing medium questions today. So remember, moving on out, I'm going to be doing medium questions on Tuesdays and Thursdays, and easy questions on Monday, Wednesday, and Friday. I think this will provide a nice mix for myself and hopefully the viewers, because I know there's some people out there that do want to see that medium content, so I'm able to now split that up. And I think it just adds a nice little bit of spice to the stream, since I've been doing this every single day since July 16th. So we started on Tuesday and things were looking pretty good. So let's just go ahead and continue on our journey. It's exciting since mediums are still fresh. You know, it's like I'm so used to doing the medium questions, or rather the easy questions, that when I do get around to doing a medium question, it's fun. It just makes things a lot more fun. All right, so let's see. Deepest leaves sum is going to be where we get the next one. And let's see, I have done this question before, and the way that I like to solve this question is just doing a breadth first search, right? So essentially what we're doing is we're going to be doing a breadth first search, and as soon as we get to the last node here, or rather the deepest level, we'll just add these nodes. We're sort of always, we're always getting the sum of every single level, right? So it's almost like a level traversal, getting the sum at every single level, and then we just finally return the last sum that we got. And there's a clever trick that I learned about a while ago on how to do this. And let me see if we can walk through it. It's essentially using, it's almost like in some linked list questions, you may have seen the concept of using like a dummy node or a sentinel node to mark the beginning of a list, and then you can sort of return the next pointer of that dummy node, and that will bring you back to the head. In this case, we're going to use like a null or like a terminating node that's going to be able to tell us when it is that we're at the next level. So let me just start coding this out, and I'll explain to you all my thought process as we go along. So what I'm going to do here is I'm going to create, let's see, I'm going to create my queue, and I guess here I can call this like level, and I'll have my first level be root and null. And I'm setting it to root and null because my first level literally just has a single root, and then it has a null because the null is going to help me know in my algorithm that I'm about to get to the next level. Okay, and then we'll also declare another variable called sum. I'll set this equal to 0. And now we're just gonna start the algorithm really. So what we wanna do here is we wanna say while level, and maybe here, maybe I'll call this levels, while levels.length is greater than 0. So while essentially it's not empty, what is it that we wanna do here? Well, I want to, let's see, I essentially want to calculate the sum of every single one of these nodes and every single level, right? So in order for me to get the first thing inside of my queue essentially here would be const node equals levels.shift. And what levels.shift is going to do for us is it's going to pop the first node. It's going to retrieve the first node of the list for us. So in this case, we'll get 1. And just like a classic BFS or level order traversal, what we'll do here is we'll say if node is equal to null, we'll do something else. Well, what we can do in this else statement, because we know the first time it's not going to be null, right? We're going to be getting the root null the first time we do a shift. So now what I want to do is I want to say, well, sum can do plus or equals node.val. And then just like any other level order traversal, we're going to do two things here. If node.left, we'll go ahead and add levels.push node.left. If node.right, we'll do levels.push node.right. Okay, and then we'll just continue. So just with this, I want to give a little bit of an example of what this looks like. So I'll have this array here be my levels, and then I'll have sum down here, and this will be, let's just say sum equals 0. Okay, so we're starting this whole thing out, right? We say const node is levels.shift, which means we're going to remove the root. Is root equal to null? No, it's not. So sum plus or equals node.val, which is 1 here. So we'll set this equal to 1. And then this node does have a left and right, so we're going to push 2 and 3, 2 levels, right? Now we're going to come back here to the next one. So we've approached the null node, so this means that we're at the end of this current level, right? So what do we do here? We say if node equals null. Okay, now we know we're at the next level. Well, one of the first things I want to do here is you'll see that at the end, when we actually don't have anything else inside of this array, it's because we've already reached the end. So really, if levels.length here is equal to 0, we can just return sum. Else, what is it that we want to do? Well, we want to say levels.push null, right? And then we want to reset sum equal to 0. So let me show you how this works. We did the shift on the node, on the null node, right? And that told us that we were done with this first level here, the 1 level, right? So if levels.length now is equal to 0, which it's not, we don't return sum yet, but we do want to push another null here. That way, by the time we're done processing 3, we'll get to the null and we will know that we're done with this level. And in the meantime, we'll just reset our sum to 0. So now we can start calculating the sum of this level. So sum is now 0 and we reset again. Now we get to our 2. We shift 2 out. 2 is not null. So we add 2 to sum and we push its left and right, which is 4 and 5. So here we push 4 and 5. Then we shift 3 out. It's not null, so we add 3 to 2. We get 5. 3 doesn't have a left, but it does have a right, which is 6. So now we do 6. And now we get to another null, which means that we're done processing the level 2, 3, the level that contains nodes 2 and 3. So we'll go ahead and remove this null. We'll do the same thing. Now we'll add another null, right? Because that's going to help us know the ending of this level 4, 5, 6, and then we'll reset sum. Now we'll start again. We'll shift 4, not null. Sum plus or equals the 4. It does have a left, so we'll push 7, but it doesn't have a right. We'll shift 5. We'll add 5 to 4. That's 9. Doesn't have a left or right, so we don't do anything. Now we shift 6. We add 6 to 9. That becomes 15. 6 doesn't have a left, but it does have a right, and that's 8. And now we get to null again. We get to null. If levels.length is equal to 0, which it's not, we push null, so that way we know that this helps us determine the end of the level with nodes 7 and 8. And then again, we reset sum to 0. Now we shift 7, make sum 7. It has no left and right, so we do nothing. We shift 8. We set this equal to 15. It has no left and right, so we do nothing. Now we finally shift that last null out, and we finally get to this conditional here. If levels.length is equal to 0, we can now just return sum, which is 15, and that gives us the answer right here. So let's go ahead and remove all this, and let's run the code and see what we get. 15 and 15. Oh. (15 and 19, 15 and 19). Awesome. So 44.64. Now there is something that really we can do a little bit better, because this shift operation right here, if you think about it, right, we have like a 1, 2, 3, 4. If I shift 1, we're going to need to have an operation that puts all the existing elements one index before. So because of that, I believe that the shift operation takes O of n. So that's actually, like, if I think about it, I feel comfortable saying that, like, the algorithm, if everything in here was constant, we'd have to process every single node, right? Which would make it an O of n. It will be a linear time algorithm. But for every single one of these nodes, we're also incurring some time taken to do this shift of levels. It's going to be some factor, and I don't think that factor is negligible. So there's something better that we can do. And let me think about this. It might be in the way that I'm storing things. Like, I wonder if instead of doing root and null, what if we did it the other way, where we did null and root, and then we just pop. So I can pop root, right? I'll still do my sum, and then I can pop null. Okay, I see that's that. I add 4 and 5. Well, rather, I'll add, if I pop a null, well, let me start the whole thing again, because I went too quickly here, right? So, or rather we'll do null and root. Null and root. If I pop root, it's not null. So I add 1 and then I also push 2 and 3. Let's say we push 2 and 3. Now you see, but then that's the thing. Now we lose, now we lose like this null here, because this really should come after. And even if I try to use something like unshift to add it to the beginning of the array, that's also going to incur some time complexity that we don't want. So I think what we can use here, and I've always wanted to try and use it, is a linked list, because then it's just dependent on moving around different pointers. We don't have to worry too much about popping or pushing, right? Because what I'm envisioning that we can do, and let me draw this out because I've truly always wanted to do this and I've never actually done it. So let's see what this looks like. Imagine we have a linked list like this. Let me just make this, all right. Copy this one, we'll copy this one. Here we'll say what? Root, and this is null. Okay, so imagine we have, root and null. What would be the best way for us to do this? Instead of shifting it, what I could do is I can have a variable, like I can have this diamond right here. Maybe this diamond right here can be like my head, right? And what I want to do is anytime I shift, what I can say is I'll just get the value of, or rather I'll just get the value that's currently at head. Okay, and then I add, and then you know what, we probably also want like a tail. I think we also need like a tail node over here. That would make things a little bit easier. So what do? When we add sum plus or equals node.val, if node.left, then I can say that okay, I think I understand what we can do here. I can set tail.next is equal to a new node that will have whatever this is, right? So let's say in our example we have 2 and 3, right? So here we'll create a 2, and then we'll set tail equal to that one, and then if the right one, we'll also create another one like a 3. We'll set tail equals to this one. Okay, and then the next time we come back, when I do a levels shift, really what I should do is I should say get me the value at head and also advance head so that it's now the next one. I think this is something that we can do, and it's something I really want to try out. So let's do this. Let's say const levels now. How will this look like? We should have, should I just use like the typical head and tail names for this? Like what if I said let head equal to an object where the next is null and the value is root.val. Right, so let's think about this. Head, the next of head is null, and the value is root.val. And then here we can say let tail equals head. The reason I'm doing it this way is I just like things alphabetized, so HST. You can also, I also like sometimes doing grouping of things that are related. So like tail and head are sort of can be grouped together because they both deal with this linked list structure, whereas sum sort of stands on its own. That's another way that we can do it too. I'll just leave it like that for now. So what do we want to do here? When I get my first node, I want to say const node equals, let's see. Yeah, it shouldn't be, it should just be value equals root. So maybe here we can say const node equals head dot val. Okay. And then here we'll say const node is head dot val, and then node, or maybe here we'll say head equals head dot next. Okay, so let me just go over this very carefully. We have head where its next is null, and let me also delete all this. And we have tail. Tail should be pointing to head dot next. Okay, so we'll have tail like this, pointing to head dot next. So let's do this. Okay, so here when we get the node head dot val, which is root, and then we say head equals head dot next. So now we're here. And can I put like an H in here and a T in here just to be very clear. Okay, head and tail. Nice. Okay, so if node equals null, so if head.val, which is not, all right, so then we'll go here, sum plus or equals node.val, so root.val. Oh, see, that's the thing though, like head.val here is root. So maybe here we should say head, we have a next and we have a node. So maybe const node, I'll say head.node, right? That'll give us the node. And then head equals head.next, okay? And then sum plus or equals the node, which is head.node, which is root.value, right? And then the same thing, if node.left, so if it's not equal to null, what is it that we want to do here? Well, we want to say that tail, let's see, the tail is currently pointing to, yeah, tail.next is equal to an object that also has a next that's null, and it also has a node that is node.left. And we'll set tail equals tail.next. And then here we can do the same thing. Tail.next equals next of null, and node is node.right. And tail equals tail.next. So let's go over everything we've just done, okay? So we have head, which is this. It's an object that has next, which is null, which is this thing here, which this might actually lead to some issues, but we'll get to that in a second. Hey, Amit Kumar, how you doing? Thank you so much for joining the stream. Appreciate it. Nice to connect with you. We have node is root. Then we have tail equals to head.next, which tail will be null here. Okay, so const node is head.node, which is the root. Head equals head.next, so we come over here. If node equals null, which is not, then we'll say sum plus or equals node.val, which is going to be root.val. If node.left, then tail.next. Now, tail currently is null. So I think what we need to do here is maybe we need to set this to an empty. If node equals null, see, that won't work, right? Because it's not going to be, I think node is root and the value is null. Let me think about this. It's mostly like a way of how I want to structure this. Because if next is null, when I come over here and I do tail.next, because I can't, like, tail right now is, yeah, tail is null, so I can't do null.next. If anything, this, instead of this representing just a null value, the next maybe could be also an object literal, I guess, whose value is null. But that makes things a little bit more tricky. Like, this is sort of getting out of hand, or maybe we can also call this node. Next has a node that's null. So now let's look at this. So again, const node is head.node, which is root. Head equals head.next. So head.next is this node that has null in it, okay? Sum plus or equals node.val. If node.left, tail.next. Okay, so now this is fine because tail.next is a normal object. So now we can set tail.next as a new property inside of this object. And tail.next will just equal another object with the next being, I guess the next should be the same as this. Maybe this is, I guess this is like a great case for readability because this might be faster, but the readability is just like tanking right now. Because then I think over here, head.node, but the node can be this, which I think we also have to do if node.node. because it could be one of these. Let's see, if node.node equals null, if levels.length, and now we also have if levels.length equals 0, which I need to figure out what that would be. Levels.push. Yeah, maybe this is getting too tricky. Even though it was a cool exercise to go through, like maybe it's getting too tricky, and now I'm wondering if we might be better served just like moving on to the next question. So what happens at the end if we have, I guess if head, this would be if head is null. If head equals null, return sum. Else, what is it that we want to do? Probably need to just push. I guess we can say tail.next equals something like this, where the next and then node is null. But I feel like I'm a little bit all over the place. Just for fun, let's see if this even runs. Oh, well, levels.length. So here, I guess it'll be the same thing while head. But are we ever gonna be, okay, head.next, okay. Node.node. Cannot read properties if node.null head equals head.next. If node.node is equal to null, If we do if not node, or maybe we just say if node is equal to null. Wow, okay, we got wildly different numbers here. Yeah, I think like as cool of as an exercise as this seems, I'd rather not spend the whole stream trying to figure out, but I do think, I mean, this could be something good. Let me actually add it to our, I have like this follow-ups notepad here of questions I really want to get to. I think it's definitely worth it to try and do this with a linked list to at least improve the performance, because as we saw before, with using unshift in JavaScript, we're going to incur some factors, some time complexity that's not constant. That will actually make it run longer. But the good news, the good thing with that is that's very readable, right? Okay, cool. Let's go on to the next one because this is pretty fun. Oh man, this question, I don't like this question. Queries on number of points inside of a circle. Is this like, can I just see the related topics to see if it's math and geometry? I don't think math and geometry questions are very like amazing. So I'm just gonna skip and go to the next one. So max increase keeping skyline. Max increase to keep city skyline. There's a city composed of n by n blocks where each block contains a single building shaped like a vertical square prism. You're given a zero index m by n integer matrix grid where grid of RC represents the height of the building located in the block at row R and column C. A city skyline is the outer contour formed by all the building when viewing the side of the city from a distance. The skyline from each cardinal direction, north, east, south, and west may be different. We're allowed to increase the height of any number of buildings by any amount. The height of a zero height building can also be increased. However, increasing the height of a building should not affect the city's skyline from any cardinal direction. Yeah, I also think I've done this one before. And I think what we need to do, like if we look at the answer here, this is 3 and this is 9. So we do, or rather no, the biggest one here is 8 and the biggest one here is 9. So we choose 8. The biggest one here is still 8. So we choose 8. Oh, I think we actually have to choose the lower one. 8 and 9, we choose the lower one, which is 8. So we choose the lower of each max because it will, if you think about it, right? Max increase to keep the city skyline, which means that relatively speaking, as long like we can increase these by a factor of however much we want, but like for example, the third building needs to be the smallest out of all of them. The first building needs to be the second smallest, the second building the third smallest, and then the last building's the tallest, essentially. Right? So as long as that was always true, we can do it. And we can, to make that true, right? Let's see if this is looking at it from south, because 9 is the top one. If I look at it from the north, we're seeing what? I'm trying to think of how this guy's looking at it this way. 3, 2. Yeah, so it means that like if we want 3 like can remain the smallest, so we can increase it as high as the highest numbers on each one of these and the smallest one of those. So we can make it 8. Here the tallest ones are 8 and 4, but like we can't make it 8, right? Like it would need to be 4 so that it remains sort of like the same form. So 3084, this would be 8487. Let's see, so if the 3, right, 3084, and this sort of still keeps the same thing, right? Where like the first building 3, then we have the smaller one, which in this case is the 0, then we have another taller one, which is 8, and then finally 4. But it still keeps the same 308. Although this doesn't keep the same, right? Because 8487. I guess they still want us to increase it and still keep a similar contour. 308. See, that doesn't make sense to me actually though, because 8487. Here, what would it be? It would be the maximum here is 8. The maximum here is 6. But we're actually picking 8. Okay. So it shouldn't be. I thought it would be the minimum of the maximums. Maximum on this row is 8. The maximum of this column is 4. So we pick 4 here. Maximum on this row is 8. The maximum on this column, is also 8. So we stay at 4. Maximum at this column is 7. The maximum of this row is 8. So we pick 8. Or rather, we pick 7. Maximum's 8. Maximum's 8. The lowest is 7. So I think what we should do is we should first figure out, we should figure out a way of storing all the maximums and all the different rows and all the different columns. And there's like a pretty nice way that we can do that. So I'm thinking of, let's see. It'd be nice if I had some like data structure like column max. We'll make this an object literal, and then here we'll have row max. We'll make this an object literal. And then what we can do is we can say for let row equals 0, row less than grid.length, row plus plus. So let's think about this. If we have this array right here, if I'm going 0, 1, 2, and 3 are each one of the different rows. So here, this one's a little bit easier, right? Because I can do the row max at my current row is the max of my grid at that row. And actually, I think we can just do grid row here. So if I do console.log row max, we should have an object literal of the maximum numbers on each one of the rows, or not. Math.max of grid.row. We do have 0, 1, 2, 3, unless we have to spread this. Okay, 8, 7, 9, and then 3. Okay, so I just have forgotten to spread this. Okay, so that's cool. And to get the same ones for the columns, this one's a little bit more tricky. But what we can do here, I guess we'll do the same thing again. Let me see. 3290. Yeah, I guess we'll just have to say like for let row equals 0, row less than grid.length, row plus plus. And actually, you know what? We might be able to, here I might be able to do for let column equals 0, column less than grid.length, since we know it's a square. Hey, Ankit Sahu, how you doing? Good to have you here. Thanks for joining the stream today. We can do like for let column 0, and here we can create like a new variable called, let's see, current column max. Now for this column, 0, 1, 2, I guess this will always be the same. Here it can be current column max. Here we can say current column max is the math.max of current column max or grid of row column. And then at the end, we can essentially do the same thing here. Column max at the same row, right? Because that'll still be column 0. And here we can say is equal to current column max. I think we can just pair those together. So if I do console.log of column max and row max, let's see what we get here. Okay, so our column max, so column 0 is already wrong. 0, 8, 0, 8 once. And is it doing the same thing? 2, 9, 3? Yeah, wait, maybe row max, let column, current column max of math.max. Oh, wait, no. This needs to be, let's see, grid row and 0, current column max. Huh. Because this should go column 0, current column max is math.max of 0 or grid of 0. This would be grid of 0 column, and the column is going to be doing 0, 3, 0, 8, 4. So current column max is 3 or 0. This will be set to 3. Then I'll get to the next one, which will be 0. It's still going to be 3. So why wouldn't current column max here actually get us to the next spot? I feel like column plus plus for let row, current column max at row, because row is still 0, so we can still represent this as column 0, and then row will increment by 1. So we'll say this is now column 1. These are literally both the same. I feel like, let me see, console.log current column max. It's going to print out a couple of more numbers than we're probably anticipating. But 3, 3, 8, 8, okay. 3. Oh, wait, what am I doing? No, this needs to be, yeah. I know why. I don't think I could actually put them together here. So let's remove this. Let's keep this the same out here. Because to do that, we're going to essentially need to go column by column. So it'll be row 0, and then this will be the thing moving. No, it should be row moving, and the column is going to be the same. Yeah, so here we'll need to do for let column equals 0, column less than grid.length, column plus plus. Here we can say let current column max equals 0, for let row equals 0, row less than grid.length, row plus plus. Current column max now is equal to math.max of current column max or the grid at column row. So we do the opposite here. And then now we can say column max of column is equal to current column max. So if we print this out, let's see what we get. Wait. It should be 0. No, okay. This still needs to be row column. Right. This still needs to be row column because we're iterating over all the rows. We're staying at the same column. Then we get to column 1, iterate through all the rows. That should be it. Little things that count. There you go. Okay, so column max, we should have 9487. 9487. Cool. Here we should have 8793. 8793. Okay, now that looks good. So really all we need to do now is we say for let row equals 0, row less than grid dot length, row plus plus, for let column equals 0, column less than grid dot length, column plus plus. We should be able to say that grid row column is equal, right? We said it's the minimum of the maximums. So math dot min of column max at that column and row max at that row. Return grid. Do we still have our console logs here? No, we don't, right? So let me just see what this gives us real quick. Nan. Does it not want, oh wait, no, it wants the building heights are shown, the skylines are viewed. Oh, so it's the number that we change it to. It's like when we add 5, I see. Yeah, so let's say max height equals to 0. I think what they want us to do is max height plus or equals the minimum of the maximums minus what is currently there. And we should probably do a math.abs on this. Math.min minus grid of row column. And then we get to here. So let's remove this. So it's going to be math.abs of the minimum of the maximums minus the thing that's here. So if we do, well, I guess let's just run it, because this would be like we're adding 5 to this one. We're still, oh, of course, I'm still returning grid. Okay, there you go, 35 and 35. Let's run this next one here. $35 and 0. All right, so let's just submit this and see what we get. 42.06. Yeah, so if we're going through this, the bottleneck for sure is this. And even these are all like, even if some of these, like for let row, this is just going to be n, because we're not also going through each of the individual columns. We're just going through the rows. But then this is essentially doing the column piece for us. So this will be n squared here. Let's see. For let row, this is also going to be n squared, and this will also be n squared. So our bottleneck is n squared. So it's a quadratic time complex algorithm. And the space complexity here, well, the column max, let's see, column max is only going to have 4 keys, and row max will have 4 keys. So I guess it could just be grid.length plus grid.length. Or really, if it's, I guess it would just be, because the whole thing is n squared, but we're just doing one piece of that, which is just n plus n, which might just come down to n. But that doesn't make sense though. Or I guess it will be n, where n is just the length of the grid. So it'll be n space complexity and n squared time complexity. Now let's see what the discussions say. Easy and concise solution. Okay, so the complexity is n squared. So for grid ij, it can't be higher than the maximum of its row, nor the maximum of its column. The maximum increasing height for a building is min row minus, okay? The first loop of grid calculates the maximum for every row and every column. Oh, so I like how they keep everything in one loop. So this is the row and this is the column. Row is the maximum of row I. Now, how does this one do it here? Or grid of ij? Column n0, nij, row of I is the max of the current thing at row I, or grid of ij. Also, they're just combining everything into one. But that's essentially what we did. So I'm pretty happy that it at least checks out with the highest voted solution on LeetCode. All right, cool. So that was this one, encode and decode tiny URL. I have seen this one a lot. Never actually done it. Do I want to do it? What's like the next one we have? Minimum amount of time to collect garbage. Why is this one? This one has like a really bad... Drink water. If you have water next to you, make sure you stay hydrated. I just had a nice swig of water. Let's not do this one just because the like to dislike seems really bad. Let's get to this one. Okay, nice. This looks good. I have a feeling when I see minimum amount of time, there's like this really nice website called Sean Prasad LeetCode. And I like the tips that he gets here because I think he has, well, if asked for a maximum minimum subarray / subset / options, then we do this. So is that what we're being asked here? Minimum amount of time to collect garbage. We're given a 0-indexed array of strings garbage, where garbage of I represents the assortment of garbage at the ith house. Garbage of I consists only of the characters M, P, and G, representing 1 unit of metal, paper, and glass garbage, respectively. Yeah, that website is like super OP, man. It's amazing. Like this is also like another website I recommend. It makes it like really nice just to start from the top and just literally go all the way down to the bottom. That's like a nice journey. Maybe one day we'll go through this too. That could be something else that I add to the LeetCode channel, just going through Sean Prasad list, you know? I think people might want to see that. Is that something that people watching will be interested in if I just did videos going through each question of Sean Prasad? Like make it a playlist? So you're given a 0-index integer array travel, where travel I is the number of minutes needed to go from house I to house I plus 1. There are 3 garbage trucks in the city, each responsible for picking up 1 type of garbage. Each garbage truck starts at house 0 and must visit each house in order. However, they do not need to visit every house. Only 1 garbage truck may be used at any given moment. While 1 truck is driving or picking up garbage, the other 2 trucks cannot do anything. All right, let me see. Let me actually do something completely random, not related to the stream. Just going to put the AC on in my house. All right, so what does this mean? GG. 1 unit of metal, paper, and glass. Metal, paper, and glass. Okay. The paper garbage truck travels from house 0 to house 1. Travels from house 1 to house 2, collects the paper garbage at house 2. Altogether, it takes 8 minutes to pick up all the paper garbage. Where travel I is the number of minutes needed to go from house I to house I plus 1. So to go from house 0 to house 1, it takes 2. Okay. The glass garbage trucks collects the glass garbage at house 0, travels from house 0 to house 1, travels from house 1 to house 2, collects the glass garbage at house 2, travels from house 2 to house 3, collects the glass garbage at house 3. Altogether, it takes 30 minutes to pick up all the glass garbage. I mean, do we just need to go like, okay, so this is going from, it takes 7 minutes. So does it take a unit of time? Picking up 1 unit of any type of garbage takes 1 minute. So this is 3. And then to go from 0 to 1 takes another 3 seconds. And then we have 1 to pick up here. Okay, that's cool. Then to go to, okay, so what? That's 7 minutes, right? It takes 15 minutes to pick up all the paper garbage. So we're going from 0 to 1. That's 3. And then this is 4. And then 1 to 2 takes 10. So that's 14 plus another 1. Okay, so I think I understand what they're saying. Now, I'm thinking of like a brute force solution almost. And I'm like wondering, only one garbage truck may be used at any given moment. Now, do we have to go? Each garbage truck starts at house 0 and must visit each house in order. However, they do not need to visit every house. So like, it'd be nice to know ahead of time if I even have. Yeah, I think what I would like to do is like, I should create indices of where I have glass garbage. And what I mean by that is, let's see, what would be like a really fast way to do this? Like, it'd be nice if we had like, oh wait, that's the wrong place. I should have something like at index 0, we have G1, okay? And then at index 1, we have P1. At index 2, we have G1, P1. And then at index 3, we have G2. So we can do here now is like, we can very easily decide, like if we're just going from, oh, well, see, we don't have to visit every single house. So do I have, let's see. And can I also do this like all together? I don't need to really, I mean, we could just visit every single house and then tally up all these individually. Because this would be 1, 2, 3, 4, 5, 6 plus 2 plus 4 plus 3, right? Because that's 6 and that's 9. Oh, that'd be nice if that was it, but no, it's not. Because this is from 0 to 1 is 2, from 1 to 2 is 4. Okay. Oh, I see. The other trucks can't do anything at the same time. I think that's what it was talking about. How's the 100% speed run going? Yeah, hey, what's up, No Condom Chris? How you doing? Good to see you around again. Yeah, I think it's going pretty well. I mean, I decided that like instead of doing everything sequentially, I wanted to mix it up a little bit and do like medium questions on Tuesdays and Thursdays because it helps me learn more. It makes things a little more interesting, a little more fun. And I also realized that a lot of people that watch the stream, they also want to see medium content. When do I think I'll finish all the questions? Honestly, I have no idea, but I'm mostly just like having fun with it. Like for me, it's more about, as cheesy as it sounds, the journey is more important than the destination. So I just want to see, like, this is mostly an exercise in, one, can I actually, like, how many LeetCode questions can I actually do? When I started this back on July 16th, I really didn't even think I'd make it past 100, and now we're sitting at like almost 300 questions, so that's awesome. That's like one thing. The second thing is mostly just to see, like, can I grow a YouTube channel? Can I actually have fun putting new content out about things that I enjoy doing? And so far that's proven to be the case. Like I feel like I'm doing well in that regard and I'm having a lot of fun with it. So those are like the biggest two things. And really just to get in touch more with the software community. I think that's fun. Okay, so I think what we could do instead of this is, because I want to know, like, let me see, 0. The thing is, if I go from 0, let's say I know there's going to be a garbage in 0 and a garbage in 2, but this is only the time that goes from 0 to 0 plus 1. But if I want to go from 0 to 0 plus 2, right, immediately without having to go through each one, we can also do something a little more brute force, which is where we essentially calculate all these frequencies, right? And then I have 2, 4, 3, so I can just say, like, here I'll do a 1, and then when I come over here I'll add the 2 because I changed indices. Then I don't add anything here. Then I come over here, I'll add a 4 because I just changed indices. If I have a 1, I'll add it. Then I'll come here, I'll add 3. Yeah, I think that could be a good way of doing it. Let me show you all what I mean. So let's say here we say materials map or something. Like, yeah, materials map is an object literal. So what I want to do here is we can say for let I equals, or we can say let house equals 0, house less than garbage dot length, house plus plus. What can we say here? I guess we still need to go through each individual thing here, right? Let's see. So inside of here, we want to say for let, let's see, maybe instead of, I'm calling this house to make it very clear, but what is this going to be, like house or house material? I guess for let house material equals 0. But see, this is just making variable names long for no reason. But hey, well, let's just go like this. House material is less than garbage at that house dot length house material plus plus. But see, now we have this whole thing that's annoying, having this go way out there. Let's just, you know what, let's just use I and J. This will be I, this will be I, this will be I, this will be I. Classic I and J, because I want to keep everything like this, dual pane. Okay, so what we can say now is, let's see, materials map at I, J, or no, this will be materials map of I, which is going to be the index 0. And now the key, we need G, and G is going to be what? G is going to be garbage of IJ is equal to this whole thing plus 1 or 1. So if I print this out now, console.log materials map, hopefully we should end up with something that looks like that. Is it because, oh, that's annoying. Okay, I need to kind of do a double thing. So materials map at garbage IG. Now materials map here, materials map at I. Okay, maybe what I should do here is I should first set materials map of I equals this. Okay, there you go. So now we have 0, we have 1G, 1, we have 1P, 2, we have 1G and 1P, and then 3, we have 2 Gs, top G. All right, so what we can do here, now we can just go through, let's see, but this is minimum amount of time. So this, I might be doing this in a brute force way. Maybe I'm doing this naively, because what I would like to do is, I mean, I'm gonna have to do this 3 times. So we should make this into a function. We'll figure that out in a second. But what I can now do is whenever I, okay, so let's set let minimum is this. Let's say let travel index. Let me actually clean up a little bit here. This is, we're gonna make this let travel index equals 0. That's gonna be the index we'll use to go inside of this travel. What we can now do is we can say for let I equals 0, I less than garbage.length, I plus plus. Right, we first want to add, so we can say minimum plus or equals materials map at I for the current letter, which is G, and then to the minimum we also had the time to the next index, right? So then we say minimum plus or equals travel, and this is what, travel at travel index, and I'll use this postfix operator to increment travel index when we're done. Now let's see, I listen, so then we'll get to P, we'll be looking at 4. So from here to here, I'm going to do 2. From here to here, I'm going to do 4. And from here to here, we're going to do 3. So maybe we shouldn't. Let's think about this. I'm going to do minimum plus the count at here. Then I'll add 2. Then I'll increase travel index. So I'll add nothing here. Oh, but this is, oh no, 0, 1, 1, 2. And then 2, 3. Okay, that's fine. But now travel index. I'm gonna be at index 3. but I'm still going to be, I'm going to be outside of here. Calculate that, add it to that. Then we're at GP. We just moved from P to GP. That's fine. We calculate all of GP. And then we can just do GG. And now we don't add anything else here anymore. So here we only do if travel index is less than travel.length. We'll go ahead and also add minimum plus or equals. So I think this is going to take care of one. What we can do here, we can do some crazy JavaScript thing here. Or I really want to go through what G, I want to go through what MP and G. So let's say we had a function called const calculate minimum time, calculate minimum time. Here we'll take a material. We can move minimum and travel index inside of here. We'll move this for loop inside of here. Then for let I equals 0, I less than garbage dot length, I plus plus, minimum plus or equals materials map. Here we'll do material. And then we return minimum. Minimum. And then I guess, you know what we could do? We could do something like M, P, G. I can say return. We'll reduce this array. We have an accumulator and a value. And here we'll just return accumulator plus calculate minimum time for val. And then here we'll set this to 0. I'll explain all this once I'm done. But let's see if this gives us what we want. That'd be pretty cool. This is a very interesting question. Okay, so we have nan. That's awesome. So let's figure out why this isn't working here. So return accumulator plus calculate minimum time, where we take the material MPG for let I equals 0, I less than garbage dot length. So minimum plus or equals materials map at 0. So we should have something like materials map at 0 for the given material, which is G. Ah, okay, I see. Because some of them won't have it, right? So only if materials map at I material is not equal to undefined, then we'll add it. Because as soon as you get to like P, for example, it's not going to be in here, but it'll try to add P, and that's going to be undefined. And that could be, yeah, because we know that undefined will make that not a number. 33 and 21. Okay, so I'm very curious to see like the result of each of these individual ones. Return minimum. Console.log. Let's do material and let's do minimum. And let's see if everything checks out. Obviously it's not going to, because so like M already is completely wrong, right? MPG, here we're getting a 9. Like we literally shouldn't get anything. Minimum is 0. So if, oh, and it's only, let me see, number of minutes to go from house 0 to house I plus 1. But we don't need to visit every house because there is no, there is no metal truck, so we don't need to consider it. Now, what if there's only, oh, because it goes 1, 2, 3, then it goes here, that's 6. Do 1, 7. And then we don't go to the next one because there's not a next one. Well, that certainly made things more complicated. But I like how far we got. I feel like making a data structure like this was pretty interesting. We still have some work to do, but we definitely made a lot of progress on this one. I do like this question. I won't put it on my website yet because we haven't actually finished it, but this is definitely a good question. I think we need to figure out, like, we should only move there GPG, and the P starts here, so the paper garbage trucks travels from house 0 to house 1. Oh, so we need to visit them in order. So I guess we only, well, let's think about this. What happens if, like, there are no, in this one here, there is no metal garbage, so we don't have to consider any. But like, if there was metal garbage in the last one, we would do something, right? We'd still have to move to each one. So we need a way to figure out earlier if there's any. So maybe instead of having something like this, you know what we should do instead? We should have an object where, this is what I'm thinking. We have an object instead where we sort of reverse it, where G maybe contains an array of something similar, like where we have, let's say, like in house 0 we have 1, right? And then in house 1, this is our frequency of 1. That way it's very easy for us to decide where G is. Like, G starts at what index? Okay, that's 0. If G starts at index 2, then we can, or I guess we still have to go anyway. I guess it doesn't really matter. It doesn't really matter where we start. It's mostly of, do we start at all, if that makes any sense. Like, it doesn't matter where, like, M is here. Like, M could be in this last position here. The most important thing is, do we even have an M at all? Because if we have an M, we'll have to go from 0, 1, 2, 3. Right? Isn't that what they said? Because P, let's see, what's a good example? Like, P has to go from 0 to 1. You can't just go directly to 1. Well, I guess going directly to 1 is the same. Well, no, you can't just go directly to 1. You have to go from 0 to 1. So maybe that's one thing that we can do here. Yeah, I think we can have, like, yeah, at position G, like, we take a string. We're going to say, okay, this is G. And now we start looking at each one of these. Like, for G, we have an array of where the G's are located. Something like that. Or maybe even having another object that says G in house 0 has what frequency. Wait, but then isn't that, I guess it's just, yeah, instead of house 0 to G, maybe we can say G to the house and the frequency. That would be interesting. Yeah, G and the house and the frequency. Can we try that real quick? Should we try that real quick? Can we come up with something like this? Let's try again. Let's like comment all this out. How do we want to do this? Because we'll need to take, so as we're going through this string, we'll have a P. Inside of P, we'll have 0. I guess we can just start. Yeah, I can say materials map here is equal to G, or we'll just do it exactly how it said here, right? Like MPG, M. Let's do M, let's do P, and let's do G. And then what we can do now is we can still go through the garbage. So for let I equals 0, I less than garbage dot length I plus plus. Maybe what we do here, we don't need to do this anymore, right? Now we just know, yeah, here I think we can just say, oh yeah, we still need for let J equals 0, j less than garbage of I dot length, j plus plus. What if we said here like materials map of the current letter that we're on, which would be garbage of I, j, and here this would be I to represent the house, right? So this would be like garbage of ij, which is either of MP or G, and then I at the current house should be equal to this plus 1 or 1. So now let me again see what this does. Console.log materials map. Could this be a better way? Oh, let's comment this out. Let's run the code. Okay, so we have no m's, and now we have p, right? So now check this out. Now we have, for p, we know we have 1 at house 1. At house 2, we have 1. For g, we have 1 at house 0. At house 2, we have 1. And at house 3, we have 2. So maybe what we can do now is, knowing this information, we can always travel to each one of the different, like we can go from 0 to 1. Like we'll go to 0, we look for 0, there's nothing there. I think we can we can still keep this, I think, or like some modification of it. This is getting very cool. I like this a lot. I like this question a lot. So let minimum equals 0, given the material. But now let's see. At P, let's think about this. For let I equals 0, I less than garbage dot length, if materials map, so we don't add anything. So I think we can just sort of change this. Now we can say if materials map at material and the current house, right? So material will be G and the house will be 0. So we can add a minimum to that. And then we'll also add the time. And then here we can return minimum. And now, yeah, what if we just do it? What if we just do it now? I feel like there's something I'm missing, but I feel like this is a maybe better way of doing it. Let me remove all this. This would be awesome if we get it. Okay, I think I probably removed a little too much. Line 57. Yeah, I didn't like something I did here. Let's put this there. Probably, wait, because sometimes when I do those, like, let's remove everything up to here. So materials map, that looks good. We have 4. Calculate this. So our for loop is here. Okay, there you go. I think I see the problem. This belongs there, and we need this should not be there. We'll do that. We'll return minimum and do this. Let's run this now. So minimum plus or equals materials map. Oh, I didn't also change this. Material and I. $33 and $21. So here, let's think about this again. It'd be nice if I can get like, I need to print out my materials map. Console.log materials map. We're gonna try something different here. I'm gonna open VS Code. I'm gonna copy this. I'm gonna copy this guy inside of here. Let's open up some like. I don't know, just open this file. This is not going to format it for me. Oh, I guess it isn't. Oh, okay. Oh, that's fine. I just need this for reference. So we're gonna do MPG, and our travel time is 243. Okay, so we start at 0, and we look for the G. So if materials map of G0 is not equal to undefined, which is not, we can add a 1, okay? And then we'll also add the 2 to the next one. Then we get to P. So what happens here, like, we still need to add, we don't add anything for P, right? Because here I say if materials map of G at 1 is not equal to undefined, which it is, we don't do anything, but we do add another travel time. So that's what, 1 plus, so we did 1 plus 2, now we add a 6 because of the 4. We come over here, we add another 1, and now we're about to add a 3. And then finally we're here, and that's what, plus 2? So it should be 1 plus 2, or we'll do 1, then we'll come over here, plus 2, that's 3. Here, we don't do anything, plus 4, that's 7. Then we add a 1, that's 8, plus 3, 9, 10, 11. So we'll get 13 for that first one, right? Let me see, 8 minutes to pick up all the paper garbage. Oh, the paper garbage, okay. And the glass garbage, 13 minutes, okay. So we got 13 for that one. Let's now see what happens when we get to M. Oh, but see, that's again, like, we're not adding, I guess we only, so we're not adding the M, right? Reduce, okay, so let's do this. Let's open this guy up. Let's also set this here. We'll add one of these, we'll close this. Here, we need to say that if, let's see. Oh, and I guess there's really no way, there's no nice way for me to know if this isn't, I mean, okay. If object.keys of materials map at value dot length is equal to 0, then we can just return accumulator. Else we return accumulator plus that one. Okay, so like the way that I'm using to see if this is an empty object is I'm just seeing if there's any keys in it, which there's not. So I say a material, like object keys of materials map at material, materials map at material, which is val. If the length of that is 0, I just return the accumulator. Let's see what that gives us. Okay. Oh yeah, this shouldn't be in here. Let's see, this shouldn't be there. Now the 0 should be out here. What did it not like here? Object.keys of materials. Oh, materials map at val dot length. Let me remove this console log. Oh my gosh. I mean, we're getting close. I really feel like we're so close. We're so close. So if we never have one, we don't even consider it. We got to the G. Let's see what happened to P. If object.keys, that's fine. So we turn accumulator plus calculate minimum time of val. So we don't add anything to minimum, but we do add the travel. So that's 2. Come over here, we add 1, that's 3. We come over here, we add 1, that's 4, plus, no wait, okay, we're at here, we add 0, then we go here, that's 2. Had ear, that's 1, that's 3. We go to the next one, that's 4, that's 7. We add 1, that's 8. We go to the next one, that's 11. Okay, so I do see that I'm maybe doing something wrong here. Collects the glass at, so travels from house 0 to house 1. So that should be if materials map of material at I. So let's look at P. There is nothing there, so we don't add anything. But travel index is less and travel length. So we do add this first travel index, which is 2. We go to the second house. Travels from house 1 to house 2. No, that's the glass garbage. Oh, here we go. Collects the paper garbage at house 1. That takes 1 unit because there's only 1. And then we go from 1 to, so that should be 3 already. Now we go here to 7. Oh, okay. I see. We also only need to go, it's not that we need to go through the entirety of garbage length. We need to check if there's even something else. Oh, and it might not even be like in the future. What I mean by that is like, we need to go in order, but we don't need to visit every house. Like, what if there was only M's? If there's only M's at the end. Oh man, this becomes trickier and trickier, but I feel like we're so close. We're so close, guys. I think now the issue is that like I'm still considering the last house even though there are no P's. But do I always need to check the next one? Like in order, does it mean that I don't need to visit every house? It's almost like I need to know if there are any P's after 2. But it might not be the like what if it was just like P and then GG and then another P after this? Like if there was another index after here that had P. What's a nice way of knowing that? I'm not entirely sure right now. But anyway, we've gone, 18 minutes over than the normal streaming time. But I had a lot of fun with this one. I think this one is very cool. I feel like this definitely flexed my brain. It's exactly where we want. It's like, I don't think it's so challenging that it's impossible, but definitely challenging enough that it makes us think way harder than we ever did about any easy question. So I'm very happy that we did this. So I'm going to wrap the stream up here. Thank you all so much for joining. If you like what you heard, if you like LeetCode stuff, follow me on Twitch. Follow me on my YouTube channel. My YouTube channel is where I put the majority of my uploads. I have a lot of things like the daily LeetCode live streams. That's live right now. And of course, I also have other things like playlists from different LeetCode Explore cards. One of the newer ones I just started was Arrays 101. I have some front-end JavaScript project stuff that I'm doing. And I'm actually working on getting my next podcast episode ready that I'm planning to have recorded next Friday. So very excited for that, and I'll be putting that on Spotify and also the Castware YouTube channel if that's something that you're interested in. So with all that being said, again, thank you all so much. Hope you all had a great Thursday, and we'll see you all tomorrow for another episode of Daily LeetCode.